The point is that these things have been around for a while. And I always mention that I have a team member in Open Parallel. A gentleman has a PhD in artificial intelligence from the University of Edinburgh. Now, the point is that he graduated in 1988, and that's 35 years ago. That means that he had lecturers that were experts in the field years ago. So I'm not saying that this is not fantastic and new, but if you have been in the field, you have seen coming. I want to share it's the website of my conference, Multicore World. And if you go to the presentation, you just need to scroll down to Professor Jeffrey Fox. And if you go to slide number 25, and you do that while I chat an extra minute. But what hopefully you will be able to share with the audience is that these things has been around for a while, and people have been looking at them. And what we see, like everything in high tech, things first need to be discovered, then need to be tested, and then pushed as a product. And that's what we're seeing, a product pretty much on a freemium mode. So Sam Altman has been around for some time, and rest assured that everything that you ask to ChatGPT, they are extremely happy for that, because that just feeds the next interaction. New Zealand is, yeah, that's the next one, the 25, which is a little bit, there we go. You can see a few numbers there. So you have it open this way, I don't need mine. You just look at, those are billions of dollars. So how much it costs to train these things. And we can take a lot of considerations about power, or there are a lot of things into consideration. But I think that, going to your question, how do you think that New Zealand should respond to the hype? In the same way that any mega trend controlled by large corporations, it's arriving to our shores. In the same way that, I don't know, 30, 40 years ago, New Zealand got exposed into Microsoft Word or Excel. So you cannot, you should not look at these things without the context of why are these things happening. So there are a number of variables. It's the fantastic advance of technology, which didn't happen overnight. It's the reason why these technologies are being pushed. Well, there is a progress in hardware, software, which has been evolving for many years. And there is a product. I mean, there is a capitalistic interest in making this something feasible. I can spend the next 3 hours discussing all the consequences, but my short answer is, in the same way as New Zealand should look at this in the same way like any other hype, because it's here to stay. It will change a number of things. It will not change absolutely everything, in the same way that internet is still not accessible everywhere. And I am not a negationist. I'm absolutely positive. The most important word in your question is hype.
Mm. Yeah.
And
absolutely.
I'm not trying to minimize that, but we need to stop. The moment that you see every novelty quoted every day in 6 o'clock news, something is just, and for 30 seconds, not for. So, I mean, 30 number of years ago, it was a model called Crossing the Chasm. Maybe someone remember that grow and a plateau. So you have the innovation, and then there is a chasm from the innovation going into the adoption and different stages of adoption. So the case of the microwave, the first adopters, the microwave oven, were the guys who bought it for $1,000 and even put the hands inside the microwave to see if it worked or not. Those are the enthusiastic. Well, the AI and the language models has been around for a while. This is now crossing the chasm. And in a few days, as I say, I live in Wamaru, I'm going out of curiosity to participate in a local business meeting about the potential of ChatGPT for business. And the person delivering is someone from the Wamaru Public Library. And that's not disqualifying. It's just saying that, look, so it's not a PhD in AI, what I'm trying to say. So AI and large language models are crossing the chasm. But as I wanted to show with this slide from Professor Jeffrey Fox, which has been around for a while, for the physics enthusiastic, he used to be he worked with Richard Feynman, which is an interesting name. We know about these things, and we know how much it costs. So they are cornering pieces of market, and these are the standard business wars at a completely different scale. Maybe I stop here, but I can keep going.
Maybe one interesting aspect of this is that you're actually touching with this slide that you pointed out is about related to the cost of training and essentially developing these models. So I guess here the key question is, what is the role of supercomputing in this AI, in this new era of AI?
Well,
and whether you see that we have the capabilities in New Zealand to even be a significant player.
Well, you need to discuss what do you mean by significant player, because New Zealand, it's a small economy far from a number of places, pretty much anyway. That's why we are here. We love to hide in the end of the world. But this wouldn't happen without high performance computing. Now, we do need that, and we will probably touch this topic in the next number of questions. Now, do we need to train these models? Yes, but do we need to use other models or our own models? This brings me back to my original point about Microsoft Word. Some people use it, others not. My point with Word, which is good and bad, is that it set the standard, and not always for the general good. It set this. Capitalism is good for capitalists, and this is not trying to put a socialist flag here in the middle of the conversation. It's to understand why things happen. Now, the Ministry of Education of New Zealand has a long-term contract with Microsoft, and that allows them to give the office suite for free to high school students. Now, we know that there is no free lunch. So the same happens here. We can build our own model, imagine, for try to detect earthquakes. I live in the South Island. We have the Alpine fault, which will happen and will be a magnitude 8. Can we start to, or there is a lot of work on that, but can we keep working on that? Well, that will be worthwhile. Now, at the range of costs that we're having now, is this a worthwhile exercise? Well, as a businessman, I can tell you that someone will need to pay for it. I cannot. Should I set up a data center besides the TY pond in Southland in order to have better energy? There are a lot of considerations. The bottom line of answering your first two questions is, remember, why is this happening? This is happening because there is a business opportunity out there, and there are organizations, companies trying to corner the market because the reward, it's big, it's huge. Now, I follow certain people speaking around these topics in the world, and what comes up, and not necessarily in academic circles, but what comes up is that these days research and the research that pushes the boundaries and happens at hectic place around AI is not necessarily happening in academia. It's happening in the headquarters, in the core centers of Meta, of Google, OpenAI is now not sure how much part of Microsoft. And that's good and bad. It is. I mean, the internet can be traced back to the big labs in the US, I mean, Bell Labs or something. What I'm trying to share with your audience is that never miss the point of how these things happen in the broader context.
Yeah.
The narrative happens through, it's not good and evil. Things happen. Think in terms of religion. Religion happens for a number of reasons. You cannot take it isolated what's happening today without tracing it back into certain roots or something.
No, that's a very good point. So let's start narrowing down the conversation a bit around supercomputing, which is probably the sort of the niche or what makes this conversation particularly interesting with you. So how about if you tell us your personal story with supercomputing? Like, how did you get involved in this field?
Of course. As usual, things happen without planning. And particularly in life as an entrepreneur, things happen. You start to find your way. Now, I'm originally from Uruguay in South America. I studied engineering there. And a paper in my first year or hydraulic engineering, they taught us computing because you need to process. And the standard language at the time was Fortran. So you learned Fortran at the time in a full year paper. You never imagined that 40 something years later it would be still cool to mention it. So I won't mention that I still know how to extract a square root by hand because I knew how to do it. And later I did private tutoring and well, I made money by explaining young children, hey, this is how you extract a square root. And that's an example of how computing augment capabilities. It's not necessarily AI, but that's an analogy. So fast forward a number of decades, when I started Open Parallel, we would be just another consulting firm, distributed, no headquarters, whatever. But then I was wondering, how can I make, what's the differentiator of the organization, of the company? And then I get aware of the membership of New Zealand as a country into the Square Kilometre Array Radio Telescope Project, the SKA. The SKA, to give context to the audience, is radio telescope is different than the one that you used to see. It's not an optic. You receive radio waves. The goal and the goal of the SKA is to listen literally to the origins of the universe. So it's literally map everything that has been happening since the Big Bang. In order for that to happen, you distribute the arrays, all these radio antennas that you see in the news. And the original plan was to have hundreds of thousands of antennas distributed in different parts of the world to have a 1 kilometer times 1 kilometer, the square kilometer. In order to capture that avalanche of information, which literally it was originally planned for 157 terabytes per second. Let me rephrase that. It's 157 terabytes every second, second after second. That was exascale computing from the very beginning. These days, it's much more realistic. It was downgraded to an order of magnitude, but it's still a monumental amount of data. And that exposed me into the world of high-performance computing. So I started to go to the supercomputing conferences in the US. I started to see how these things work. About a decade ago, I came from the open source world. I built a .com. I built the first e-learning company in South America. It was a different mindset, always in high tech. I've been in the venture capital. I knew how a number of things happen. Well, the high performance computing environment, it was a different one. And then you realize that essentially was underpinning pretty much everything. So I can give you examples about how Emirates Team New Zealand use HPC, or stories about how Lord of the Rings happens thanks to HPC. HPC is high performance computing. So essentially, my exposure into that world was through my activity into the SKA, and from there, well, navigate the industry, navigate the communities, create a reputation. But again, simplifying everything, it's business as usual. You get involved in an area because you are working on that area. It's not that I wake up when I was 15 years old, I say, oh, I will dedicate my life to supercomputing.
Yeah, I see. I think something that that separates you apart from other entrepreneurs in the field is that I feel that you've always been very close to the cutting edge of scientific research, and the SKA is a really good example of that because it's a huge ICT experiment essentially, where
Civil
there's
experiment.
a lot of.
Allow me to highlight
Sorry?
that. It's the
Sorry?
largest civil IT. We don't know what
Right.
other
Okay,
organizations
we don't know what the
have.
military are doing.
And that's
Yeah.
fine. I mean, we don't need to know.
Yeah.
And
So
that's an
how-
interesting angle. Sorry for the interruption, but we don't see those things in New Zealand or in other countries. We are not exposed to the different world of defense, of the world of clearance. You mentioned my conference, Multicore World. In Multicore World, I invite a number of people, and I'm extremely proud and flattered that they come. Some of them from the big labs of the US, the national labs, they cannot travel to a number of countries. They cannot definitely go to Iran. Not that because they don't get a visa. The United States government doesn't allow them to go there, even if they are retired. So the moment that they sign into that clearance at age 18, they become, well, in a different world. And I repeat, it's a subtle message here, but the point is, we need to understand context. So you are very kind in putting me at the cutting edge of this and that. It's just where the business go. If you are involved in farming and you know a lot about wool, it's just because you have been working on that field for a long time. And of course, if you have an entrepreneurial spirit, which I declare without hesitation, you just keep asking. So I'm a professional ignorant. I learned after many years that there is many more things that I don't know than things that I do. There is a saying that if you are in a room and you are the cleverest guy in the room, you are in the wrong room. So I learned what my track record gave me over the years, and the exposure of these clever people is you learn how to ask questions, who to ask questions, and this is election year. You become very good at detecting bullshit. Your bullshitomer, it's essential if in whatever area you want to progress. Being entrepreneurship, being business, being science. And it's not that people are good or bad, it's human nature. Sorry, I'm digressing, but I love the interaction because it's much more.
Absolutely, yeah. No, I think you're spot on. That's a really good saying, by the way. I'll make sure to remember it. Yeah. So, you've mentioned the SKA. It was an incredibly fascinating project, which
it is. It's happening. It's being built.
Yeah, it is.
I mean, we are just watching from the other side.
Yeah,
it's being built.
exactly. Unfortunately, exactly. We're only exactly now New Zealand withdrew its membership to the consortium in 2019, and I think this was probably around the time when you also started looking at how can we bring all this experience about exascale computing and big science or mega projects around the idea of digital twins and specifically for agriculture. So how about if we start by you telling us what is a digital twin specifically?
Okay, let me, before that, which digital twin is another hype, but sometimes you need to use those. I mean, Other thing that I learned with the SKA is the importance of outreach. You know a lot of stuff, but if it's only yours, it's like, let me allow you, it's like my library. I love it. I haven't read all of them. I am just making an investment for my next 40 years. If I am reading to my own, that's personal pleasure. But if you cannot share it, if you cannot do outreach, and if you cannot build a community around that, it's not going to work. And sometimes you need to use words that become common in the general public. Digital twin, AI. It's fun that I talk to a lot of people and I go to different kind of meetings and, oh, what do you think about ChatGPT? I mean, a lawyer, a business guy. So that suddenly I am an authority. No, I'm being always a random guy who has been on that field. Nicola should know. Guess what? I don't. But I do know much more than many others, and at least I am not bullshitting. And apologies for using this word, but I think that everyone understands. Back to your specific question. When I entered with the SKA project, it wasn't for my particular love of radio astronomy. It's fascinating, don't get me wrong. The day that you realize that what surrounds us is only what we know about the existing universe is only 5%, and the remaining 95% is dark matter and dark energy, which are mystery, you suddenly realize that, okay, tell me more. But I always enter in the concept of SKA because it's the pushing the boundaries of computing. And that could be useful for something. The platform required to make the SKA work would be definitely pushing the boundaries of anything else. And my goal was always to use those knowledge into something a little bit more mundane, but of direct application into New Zealand, particularly into the primary sector. So the vision of Whakarongo ki te whenua, which is the name of the decadal project, Listen to the Land, it's to design, develop, deliver a platform that can compute all the inputs of data through the entire country for a number of reasons. We can go there if you wish. But that will require a significant amount of distributed computing power, which has some analogies with 100,000 antennas between Western Australia and South Africa. So now, how do you replicate those data points? How do you make that operational for a single user, for example, a farmer? Well, that's where the concept of digital twin enter into the equation. A digital twin is the trendy word of something that you have been using for many years, which is modeling or simulation. So the words are pretty self-explanatory. I mean, I'm here, and besides me can be a replica of Nicolas, a hologram or whatever, which has a number of data points that reproduce myself. Now, using humans as an example of digital twin, if anyone starts to think about the complexity of information that goes through us, I mean, we can have for example, what we call the Fitbit. That computes a number of data points. I mean, your heartbeat or time or your position regarding to GPS. But it can compute your weight. Does it compute your thinking or your soul? Or has any measurement of your thinking? It could, for example, using AI, do what Google is doing now, the real-time transcription of my voice. So the digital twin is just something that can replicate, it's a model of a unit. That can become much more complex, and that's where the differentiation happens. That's when your professional ignorance becomes helpful. The digital twin has been extremely useful, particularly in industry and manufacturing, when you can not only replicate, but forecast how a factory will behave. There are some companies that are building platform and they are already partnering with car manufacturers. The robotization in cars production is something that has been around for a number of years. Now, if you want to optimize that, you will not, it's much easier if you have the data points and then you start to make variables on that. Now, don't miss the point that that's a system which has some boundaries. Things get much more interesting and complicated when the systems start to interact with other systems, and you have systems of systems, and that's where fun begins, and that one becomes complex. So if I tell you about a farm, the first thing that you need to decide is what are you going to measure. The next thing that you need to decide is who are you, from where those measurements will come from. Are your own, or are you relying from satellite data? Oh no, satellites cover everything. And they are owned by whom? Remind me?
Yeah.
There are, in Southland, some farmers rely on weather from the Norwegian meteorological service, because for some reason it's much more reliable than the Met Service or whatever. I'm not making judgment, it's just a fact. Still, it's owned by the Norwegian, who maybe they have a satellite somewhere. So the digital twin brings these things together, but it's an absolutely fascinating, complex problem. And because it's so mundane, people just say, oh, I go and buy a digital twin. And of course, you have people selling. But I use this silly analogy. You have a number of ingredients. Let's say that you want to cook something, a hamburger. It's pretty simple. But still, you have a difference between a McDonald's, something that you do at home, or a 3-star Michelin hamburger. It's still mince, but there is some magic. And in the 3-star, I hope that you will have, I don't know, a different experience. Digital twins, and it's a little bit sad experience comparing with hamburgers, but what I'm trying to say is, it's now a mundane thing, but you need to deliver. You need to make it useful and cost effective, which is the other thing.
Yeah, no, I think it's a really good point in terms of, on one hand, you have, you touched on the data collection or the data availability, because obviously to create a digital replica of something, you need to have the ability to collect data that is relevant for what you want to, for whatever function you want to simulate, right? And then on the other hand, you also need to build a system that is capable of ingesting and managing and creating essentially something useful out of it, right? So this ties to the concept of edge computing, which is I'm not sure it's a hype word because it's a lot more in the technical space, but it's a very relevant one for in the space of digital twins. So how about if we talk about your experience with edge computing and the challenges of implementing a system at scale?
Well, edge computing, again, I agree, it's hype. And we wouldn't having a general conversation if not about terms of general knowledge. So yeah, it could be. So anyway, edge computing, the computing has happening centralized and decentralized. Once upon a time, you used to have mainframes. So everything had to go into that big box somewhere. Then the personal computer revolution happened, and that disaggregated all these mega systems. Then some things, but still things were in servers somewhere. Now then the cloud happened, and everything had to go there. Well, guess what? That's not necessarily practical in a number of situations. Of course, you have the point of latency, and with regards, for example, self-driving cars. There is a classical example that there is a self-driving car. Example, it's fictitious. and is arriving to a corner, and there is an old lady crossing with the grandchildren, and there is a cliff and there is a mountain. So the system needs to ask itself, attention, what should I do? Kill the nana, go through the two children, commit car suicide and take my driver down to the cliff? Attention, what's my decision? And guess who is asking? It's asking the insurance company. It's asking the liability. But all these questions not necessarily are easy to answer within the car. They go up to the cloud where the model is taking those decisions, considering, okay, are the kids less than 10 years old? Whatever. I'm using a little bit shocking examples, but rest assured you will remember that. But it's the insurance, it's the liability, and that depends how has been programmed that. So I'm going back to the AI concept, but then it takes another extra second in order to process that. The decision is perhaps not optimal. So the edge computing is when it's capturing the data, it's recognizing elements here and there, and it's taking the decision on the spot. And that has been able to, that happens in the last number of years, let's say the last decade or even less, when the processing power of microprocessors or computers on the spot are equivalent. I mean, the glorious supercomputer. This is a cliche, but it's worth repeating it. My iPhone is 14 or something, has more computing power than the computer that sent the man to the moon. Well, that's a dramatic change. So you can actually take decisions on the spot. That also happens with one of the biggest data processing issues, which is computer vision. So taking data points in lines of code is one thing, but processing vision, that's the biggest challenge. Edge computing allows you to do that. And if you start to have a network, there are many challenges, which, okay, do you have 3G, 5G? Well, in the agri sector, there are people experimenting on using the wideband on TV, which is unused in rural areas. So what I'm trying to highlight is that there are a lot of exciting things happening, but then suddenly you need to put them together and you need to transform them in something operational, useful. So the reason why I entered into the agri sector is it's one of the comparatively less digitized in regard to other industries. I could go into education or into health, which are also non as computerized in comparison than others. But if you can go to high frequency trading, which is the realm of high performance computing, you can make millions in seconds. Well, guess what? It's just not that trivial. And farming, and there are three things that at my age you start to think about the future of the type of world that you want to leave behind. And there are three things that matters to me, which are climate change, earthquake detection, and the future of food. So how you balance those things? Well, the project Listen to the Land aimed to develop a system that can take that information, and I'm not saying that it will become a commercial success, at least will trigger conversation like this. These are things that I could do. I can do with a team. I can do in a collective.
Yeah.
And I'm not relying on government funding. I'm not relying on how can I say, corporate roadmaps. It's not to be a staunch independent. It's just do things and making progress. And having fun. That's essential.
Yeah, absolutely. Yeah. No, that was really good. Thanks. Let's move forward.
I'm not sure if I'm answering your questions, but I'm having a lot of fun.
I mean, no, this is it's been great. And for the participants, feel free to post questions as well, right? I wanted to touch base on the conference that you organize, Multicore, right? You've mentioned before that you've been doing this for a while, and you managed to get this really high caliber speakers to come every year. I guess the main question here is how this experience of organizing an annual meeting like this on a topic that is not always in the spotlight, supercomputing. How does that influence your own professional growth, the growth of your company, and sort of your vision as well?
Look, multicore world, I mentioned a few minutes ago the concept of outreach. So you can be doing stuff, but if no one knows about it, or even worse, if people knows about it but has the wrong knowledge. So it's essentially what are we doing here? You are doing your job in the data science lead or whatever is your roadmap, and then I'm more than happy to contribute. We are outreach. It's an important concept, and anyone in academia or industry which is not considering that, I urge you to start to think. And the best sounding board of outreach is your family. So yeah, every time that I change areas, I challenge my wife or children. If someone asks you what's your father done, well, it's just not trivial. So I simplify by saying, look, strategy and technology consultant. That's it. And the word consultant sends people away. So that's easy. Multicore world starts as an answer to promote the work that we're doing with the SKA. But at the same time, already with a long view of distributed computing towards the primary sector, towards the distributed platforms, towards heterogeneity. A previous company, I started about 25 companies in my career. Some lasted 3 months, other 20 years. That's life of an entrepreneur. So one of my companies, which was based at the Center for Innovation at the University of Otago, had a direct contract with Sun Microsystems, which people with some age will remember. I mean, the internet, the first internet era was built on Sun workstations, and I'm talking about 2000. So that was between 2005, 2008. And at that time, Sun, which has been always a pioneer, but as I always say, being a pioneer has advantage and disadvantage. And one of the disadvantages is that you are the first, but also you are the first one being shot if things go wrong. So Sun was building these new technologies, multi-core technologies, and I learned a lot about that. And a few years later, when I started Open Parallel, I said, okay, let's call multi-core world, because you need a brand. And let's try to bring the best in the world into New Zealand and just have a conversation. So essentially, the goal of the conference is to get together at peer level. It's only 100 people. Each of the speakers can be a keynote in front of 10,000 people. Actually, they are in the States. But the problem that they face on these conferences is that they are surrounded by thousands of extras. I mean, PhD students, journalists, wannabe developers, everyone wants a selfie. So they just deliver a series of slides, everyone clap, and that's it. It's a little bit of hype, but it just doesn't necessarily add value to everyone at peer level. I mean, vanity, it's an important driver of people, but it's not everything. So multicore world gives the chance to have 25, 28 speakers that can be keynotes anywhere in the world, but debating in a controversial way and allowing anyone else. So, I mean, I sell tickets. I'm not in the conference, in the events management industry. One of my initial measures of success of the conference was that every year I was losing less money. So you need to have two ingredients there. A very good credit card and a very understanding wife. So it took some time to create track record credibility. Yes, New Zealand plays its part. Everyone wants to come to New Zealand. Every year I have at least one speaker, if not more, that they cross the equator for the first time in their lives by coming to Multicore World. Now, I could do that in Fiji, but no, New Zealand also has apart from the utopia, there is always someone doing something in New Zealand related to someone, being industry or academia. And let me touch again the HPC in New Zealand. There is a Professor Jack Dongara, Turing Award 21 or 22. The Turing Award is the equivalent of the Nobel Prize, but specialized in computers. So Jack, you can search about him. So my way to enter into the supercomputing conferences was, okay, if I want to get some reputation here, I need to do something. I need to give something to the community. So let's organize a panel. So I worked for weeks and months and put together a panel in 2014 or 2015, and it was accepted. These are all peer reviewed. Multicore World, it's Nicola's friends. I put the program together. That's a different story. But in supercomputing, and this is an interesting story. Bear with me another minute. I invited Jack Dongara. So it was about open source platform for exascale computing, which in 2015 was a little bit ahead of the pack. And the SKA allowed me open a lot of doors. And that's why I think that New Zealand missed that opportunity. I know that it's not necessarily cost effective from the point of view of government official, but it's extremely valuable from the point of view of things that you cannot buy. So the reputation that New Zealand built about being part of the design team, of the leadership team of that, was unique. New Zealanders belong to a number of projects, but those are leads from the University of Cambridge, from Stanford, Wageningen, whatever. So I came across Professor Jack Dongara, which I haven't met personally, but he was one of my panelists. I will moderate them. Say, oh, New Zealand, I was there once. I say, yeah. Good. And he said, did you know that at some stage New Zealand had the highest number of flops per capita in the world in supercomputing? I said, what? Yeah. And that's thanks to Lord of the Rings. And that's an interesting story. My friend Scott Houston.
Can you go in a bit more detail there?
Yeah. So Lord of the Rings, and I'm talking about 20-something years ago, but at some stage there is a battle of the orcs, which are some characters, the orcs, and suddenly there are 3,000-4,000 of them that need to attack something. And the contract was signed, and there is a deadline to deliver, and that battle needs to be by computing-generated images. But they just simply had not enough computing power. And those were the days that Weta made the production and sent the DVDs to Singapore by plane to be processed. Remember what I say about latency. So technology was there, but you need to deliver. Okay, so in order to do that battle, Scott Houston, which is a personal friend, there is another story around that, well, he just simply had no computer power. So okay, who will tell Peter Jackson in his face that we have 4 weeks to do this? We cannot do it. So either we will not do it, or we need to spend, I don't know, $5 million buying equipment. Well, the story, as you can imagine, is that, okay, you buy the bullet, you buy the equipment, you do the scene, and you go and earn, I don't know how many Oscars after that. But those are a mix of entrepreneurial, technological, and scientific decisions. And thanks to that computing power, pardon me, Weta Digital and New Zealand become one important member of the top 500 supercomputers in the world. But probably the only time, maybe Nicola had some supercomputer on that benchmark list. But it was literally the biggest amount of processing power in the world per capita. And the Turing Award of supercomputing has the first line of interaction between him and me when we meet personally. I don't know, in Dallas or Denver, can't remember, Austin. So those are the things that you cannot buy.
Mm.
Now, there is a follow-up in this story. Again, how the things keep evolving. This happened in 2003, but then you bought those machines. What do? You do not return them. You just needed to add one scene, and that's it. So Scott created what it was called the Center of Supercomputing, and I'm talking in mid-2000s. And that led him to learn a number of things. And then later he created a company called Green Button, which offered rendering supercomputing on demand, which later was purchased by Microsoft, which later allowed Scott to buy him a little boat and then send me some postcards from the Mediterranean. Now, in the middle happened 15, 20 years, and in the middle, the man literally was under the water, because that's the life of an entrepreneur. But what I'm trying to say is that you never know how things will go, but you need to try.
Yeah.
So I can sound like Sheldon Cooper if I say this, but this is a Nicola Erdo sentence. You never learn to swim walking around the swimming pool.
That was very interesting. So I'm conscious of the time. So we're gonna start wrapping up.
I have time. I'm happy.
Yeah.
This is
energizing. I think people will. Yeah. So Sijin, who's one of our data scientists, has asked a really good question to you. So I'm gonna read it out loud. It says, "Hi Nicolas. Many of our works rely on open source machine learning libraries, but if one day the big companies behind those libraries decide to stop supporting those platforms, like Microsoft started discussing this in the news, should we worry about this?"
Well, yes and no. I mean, yes, like everything that you buy. I mean, I have this, and this relies on a battery. And if the supply chain of me buying a battery of this is doomed, then I have a fantastic piece of equipment which is completely useless. So that's a part that you need to worry about. Now, if you took some steps in terms, particularly in software, that you have a community around that, and you can tweak that solution, and everything goes down to the basic concept of supply chain. And I think that COVID taught us a lot about that. So when I arrived in New Zealand 20 years ago, I realized, wait a minute, we are relying on a single cable for internet connection in New Zealand. It's just doing this, right? Now we have satellite, now we have another cable. But if, as a business person, I need to realize, okay, I'm building a business based on this supply chain, that creates a risk. It's not that I won't do it. I just need to measure that risk. So, Sijin, the answer is, you only need to think what I'm going to do if what I take for granted is no longer there. And that's the basic of scientific research and entrepreneurial progress. I can read Jen Shepard's question. New Zealand, we have a being a novel, but it feels the island of India are getting smaller and disconnected. Where do you see? I don't think that we need to relaunch. I think that we always have been here, but we have overhyped in other things. And that's why I was so passionate about the SKA. This will sound a little bit, I'm old, I can make silly comments. There is a difference between leaders and followers. Leaders are needed because are the ones say, okay, no, we will go this way, right? It's the definition of strategy. Strategy becomes from the Greek or Latin stratego. Stratego was the guy who said, that way. Okay, but we are going towards the precipice. Yeah, but we have wings. Whatever. So New Zealand, it's innovative for a number of reasons, particularly because you have a small market. So whatever, if you are in Brazil, which is an important economy, but it's not a first world economy, but you have a bloody huge internal market. I'm coming from Uruguay, a very small country, but it's besides Argentina. And we have a friendly rivalry like New Zealand and Australia. Now imagine that we don't have the Tasman Sea, that you have the bloody Aussies across without the dish. That also changed the market. So imagine that you can take a bus and be in Sydney. So you are innovative because what you do can reach others or not. If the ones that you can reach are around the corner, you're more than happy living around the corner. I mean, there is people in the South Island, I've never been into Auckland, but they have been in Paris because Christchurch has an international airport as well. So that's also innovation. Why do you need to go through something? So individuals and communities make a country innovative for a number of reasons. I don't think that we are getting more disconnected as, for example, and this is important, don't know if many of you know that New Zealand is now an associate member of the European Union. So we are in even a better status than the United Kingdom. That means that we can access Horizon 2020, which I am planning to do a few things. I'm open to your community suggestions. That's, I don't know, 90 billion, whatever currency, is not only euros, but dollars. So we are not as disconnected as it sounds. It depends what do you mean of connection. My older son lives in London. So if I go to London and someone asks me, okay, let's do business, where are you based? Oh, I live in suburbia. You take the tube, you reach Terminal 5 in Heathrow, and I'm a little bit further down the track. Yeah. So can I read what I have more questions? And that's exciting.
Yeah.
Kambuta,
so you've got a comment, from Jacob Kambuta.
The technology very much needed the primary. I would like to collaborate. Thank you. I have to go. Okay, bye. So I'm very easy to be reached, and through Alvaro, I'm sure that everyone can reach.
So just to wrap up, then, looking ahead, what are your goals and aspirations for the future, both personally and in terms of the impact you want to make through your work?
Well, let's make it the personal one, because sometimes that's what I expect for my children. So recently, my younger one graduated, so 3 children, 3 university graduates. That has a sense of achievement, particularly for a migrant. But what I wanted for each of them is to be happy, healthy, and independent. And on that order. And some people would ask, why happy before healthy? You can be happy even if your health is not. So it took me a few decades to simplify things. And that's what I go back to the outreach concept. You need to convey a good message. So happy, healthy, independent. And independent doesn't necessarily mean wealthy. You need to have independent thinking, or independent in your relation with family, whatever. The concept of independence is important. And that brings back to the supply chain, which could be on information, could be on politics, could be on religion. Happy, healthy, and independent. Business-wise or strategic-wise, I've done a number of things. I started my first company when I was 18, 19. I just didn't know at the time that I was starting a company. I was in a country with 20% unemployment rate. I didn't know other thing that a little bit of math. I started to do private tutoring on calculus. 20 years later, that became the first e-learning math academy of South America. I had my .com. So I had 20 tutors and 400 students 20 years later. But I started one-on-one tutoring. So these days, I think in terms of building something that can solve these big problems, which are, as I say, the climate change, food production, supply chain, and earthquake prevention. And you will say, well, do you think that you are God? No, I'm just a guy who understands how computer system works, without knowing necessarily how to program, but the power of those systems. And the concept of system itself is something that you start to imagine, look, if we put this here, we can use it here. If we can put this together, which is already here, or if we can invite those guys from the world then we can do something and put it together. And that brings back to the concept of leadership. And leadership in the good sense. The best leader is the one who pretty much does nothing. And you just need to call a leader when there is a problem which is impossible to solve. Because if you are a good leader, everyone knows what to do. You are not needed. Right? And this is not a new concept. It's a biblical concept. I mean, the King Solomon, okay, that kid, okay, let's cut it in half. No. So my job in the next decade is to set up this computing platform which intends to build more than a digital twin, intends to build what I call a digital nervous system, where we are taking measurements in real time and set up a mega system. And hopefully we will optimize food production, detect the next, or at least with some time, the next earthquake, and measure climate change as it happens so we can take decisions. And put that system together with high frequency trading, or learning if it will be a drought in Ethiopia, how will affect my production. Because food producers in New Zealand are price takers, are not as independent as they think they are.
Yeah.
But that's a topic for another conversation, I think.
This was this was a fantastic conversation. I think very insightful, and I just want to highlight specifically you coming from a place in the world, and your whole experience and journey to get to where you are is quite unique, and this is why I thought that this would be a very interesting conversation. There are not many Nicolases in New Zealand. You're probably a unique type of person. So I just want to thank you
My pleasure.
for giving us this time. And I really hope that we can stay in touch. We have similar aspirations in terms of what we want to do around digital twins, around building these large systems. Climate change is a strategic priority for this organization as well. So we definitely have a lot to talk about. So again, thank you very much, Nicolas, and have a good rest of the day.
Thank you very much. My pleasure. Thank you, everyone, for being there.
All right, cool.
Till next time.
Thank you, everyone. Bye.
Bye-bye. This one.